hierdie vraag sal net in Engels gekry. So ons sal vertaal soos ons aangaan. Vra my maar, as jy onseker is oor 'n antwoord, dan stuur my foto en dan sal ek jou sê. Okay. Alright. They say there, a net force F which acts on a body with a mass m causes an acceleration of A. So by vraag 1.1 praat hulle daarvan Newton se tweede wet wat ons het F net is gelyk aan m maal A en hulle sê basically ons het F m is gelyk aan A. Now they say if the same net force F is applied on a body with mass 2m. Okay, so this is scenario 1. Dan in scenario 2 sê hulle vir jou jy dieselfde F, maar nou het jy die massa is 2m. And they want to know what will the acceleration be in terms of that first A. Okay? Shall I make mine? Goed. So if we look at the first scenario, they want it in terms of A. So ek gaan hierdie ouetjie herrangskik. We have A is F over M. Princess, you need to take one of each there in front. Okay. As ons kyk na scenario 2, then I'm just going to change that A into A2. Want dit is nou 'n ander versnelling. It's a different acceleration, so I don't want to get confused between the two. Okay, then I have A2 is equal to F over 2m. Yes? Okay, of ek kan hom gaan skryf as a half F over m. Can you see that this is the same as that? Hulle is twee dieselfde goeters. So then we have the second acceleration is a half of the first acceleration. En daarom is jou antwoord B. Okay, jy het nou al so baie van hierdie vrae gekry in jou wetenskaploopbaan. This should become easy. Okay, dan by vraag 1.2, question 1.2, they say, two forces F1 and F2 are applied on a crate lying on a frictionless horizontal surface as shown. The magnitude of F1 is greater than that of F2. Okay, so as ons daar kyk, then we see we have F1 and we have F2, frictionless surface, so there's no friction. And then they say F1 is bigger than F2. Okay, so they're not the same. Right, now they ask, the crate will what? Okay, now, because these two are not equal to one another, hulle is nie gelyk aan mekaar nie. Die een is groter as die ander een. So, if this one is bigger than that one, then it means it will move to the left. Okay, we do not have F net is equal to 0, want hulle kanselleer nie uit nie. We actually have F net is equal to m times A, there's acceleration. En watter rigting is die versnelling? Well, omdat die krag links groter is, because the force to the left is bigger, it will accelerate to the left. Now, they do not speak about left, they speak about east and west and whatever. Our left will be west. So kom ons kyk na ons options. The crate will A, accelerate to the east? No. Move at a constant speed? No. Move at a constant speed? No. Accelerate to the west? Yes. So die antwoord is D. Please stop me if you have a question. Oh, I'm going too fast or something. Okay, goed, dan vraag 1.3. Sê, the magnitude of the velocity at which a rifle recoils when you fire a shot is much less than the magnitude of the velocity of the bullet. Okay, so hulle sê jy het 'n geweer en jy skiet hom en hulle sê vir jou die grootte waarmee die geweer teruggaan op jou skouer, daai teruggaan is die grootte van die snelheid terug is kleiner as die grootte van die bullet. Okay, so if we have a gun. Nee? That's good. Okay, so there's a gun. So they say we have a velocity back van die geweer, the velocity, and then we have a bullet there that goes out. velocity forward. En hulle sê the velocity of the bullet is bigger than the velocity of the gun. Okay, nou vra ek vir jou. Which one of the following statements best describes this phenomenon? Okay, nou hier kombineer hulle twee gedagtes wette. Okay, if this is a closed system, 'n geslote stelsel, and this was a collision, 'n botsing, dan sou ons gekyk het na die wet van behoud van lineêre momentum, the law of conservation of linear momentum. Nee? Wat sê, the total linear momentum before the bullet was shot, or the gun was shot, is gelyk aan die totale momentum na die tyd. Okay. Now, let's say they were stationary at the beginning. Die koel was binne in die geweer. So then the momentum at the beginning must be 0. Because the bullet is not moving, the gun is not moving. Okay, what is momentum again? It's mass times velocity. Remember, velocity, vector, direction. So kom ons sê ons kies regs as positief. Now, they don't tell us the mass of the bullet or the rifle or the velocities or anything. Maar wat ons wel weet, is dat the momentum of the gun will be negative plus the momentum of the bullet will be positive. Want die bullet gaan vorentoe en die gun gaan links. Then we know the momentum of the gun must be equal to the momentum of the bullet. As dit 'n geslote stelsel is. Okay, maar, so their momentums are the same. Maar hulle het gesê sy velocity is kleiner as sy snelheid. Hoekom? Hoekom is dit so? Because the mass differs. Onthou julle dat ons weet dat acceleration is inversely proportional to the mass? Ja? Of wat jy ook kan na kyk is hierdie. And then you can say the velocity is inversely proportional to the mass. Okay, selfe idee. Okay, right. So with that in mind, let's read our options. So let's say that the momentum of the bullet is greater than the momentum of the rifle. Is dit waar? Kan dit wees? Nee, ons het nou net gesien, hulle moet gelyk wees aan mekaar. Okay, the momentum of the rifle is greater than that of the bullet, kan ook nie wees nie. The momentum is conserved and the mass of the rifle is greater than the mass of the bullet. Is dit waar? Momentum is conserved, but the mass of the rifle is bigger than the bullet. Ja, ek dink opsie C, I think option C. Let's just read D. The momentum of the system increases because the rifle exerts a force on the bullet. No. The momentum at the beginning must be equal to the momentum at the end. It doesn't increase. Okay, so die antwoord is C. The option is C. Kan julle sien hoe baie papier gebruik ek vir my multiple choice? Please do the same. Okay, if you ask for 10 booklets, then you ask for 10 booklets. Ek het regtig daar so pak. Ek het 50 afgerol vir julle. Okay, so please use it. Goed, dan vraag 1.4. Daar sê hy, impulse is equal to the. Okay, what is impulse again? Impulse is that is equal to that. Okay, wat is nou weer? That whole thing is called impulse. Okay, it's equal to what? The initial momentum of a body? Nee. The final momentum of a body? Nee. The change in momentum of a body? What is that? Daar is die verandering in momentum, the change in momentum. So the option is C. Okay. Vraag 1.5, question 1.5. Julle moet daar een van 11 vat, hoor. A stone is thrown vertically upwards and returns to the thrower's hand after a while. Which one of the following velocity time graph best represents the motion of the stone? So kom ons kyk hierso, daar gaan die klippie gaan op en dan kom hy af. Okay? They didn't give us the initial velocity. Hulle het nie vir ons die oorspronklike snelheid gegee nie. So ons kan sommer waardes opmaak. What is wrong, Jabu? Okay? They didn't give the initial velocity. So let's say that initial velocity is 10. Then that one is negative 10. Okay? Wat het ek gedoen toe ek hierdie neergeskryf het? I assumed that I took up as positive. And then immediately after that, I can write that means the gravitational acceleration is negative 9.8. Yeah? Okay. What we also know is the velocity there at the top is 0. Okay. So if they ask for a velocity time graph, a snelheid tydgrafiek, so then I have time versus velocity. Kom ek gaan sê, hierso is time 1, time 2, time 3. So at time 1, the velocity was 10. At time 2, the velocity was 0. At time 3, the velocity is negative 10. So as ek my grafiekie gaan trek, and I have velocity versus time, 10, negative 10, then I have 10, 0, negative 10. Whoosh. So my answer there would be B. What does the gradient of this graph tell me? Wat gee die gradient van daardie grafiek vir my? Acceleration, versnelling, gravitational acceleration to be exact, which is negative 9.8. Dus hoekom jy 'n negatiewe gradiënt het. Okay, ek weet julle het nog niks geleer nie, so ek verwag nie dat julle al die antwoorde ken nie, hoor? Dis nie gister gebore nie. Kan ek sien wie het dalk nog al 'n bietjie geleer? Ek het nog meer wat gelees. Hy het op tyd ook. Mooi julle. Okay, vraag 1.6, question 1.6. They say there, an object projected vertically upwards reaches a maximum height and returns to its original position of projection. Okay, so daar gaat hy op en daar gaat hy af. Okay? Ignoring the effects of friction, the direction of the acceleration of the object during its motion is. The direction of the acceleration of the object during its motion. Okay, so it's the same thing that we have here. Exactly the same scenario. So hy word opgegooi en hy kom af. So the acceleration A. When I throw it up, what is the direction of the acceleration? Down towards the center of the earth. There's gravitasiekrag. What is the direction of the acceleration there? Is it null? Nee, down towards the center of the earth. What is the acceleration there? Down towards the center of the earth. Acceleration, gravity is always the same. Net omdat jy op hoog kom, dis jy sien in 'n cartoon movie waar die versnelling pause vir 'n oomblik nie. It's always down towards the center of the earth. Okay? They love to ask this question. So our option there, A, always vertically down. Yes, sharp. Dit is hy. A. Okay, dan vraag 1.7, sê hulle vir jou. An object moves in a straight line on a rough horizontal surface if the net work done on the object is 0. Okay, kom ons stop net gou hier daar. Object, horizontal surface. Hy beweeg, it moves, we don't know where, but let's say it moves to the right. And then they say there, the net work done on it is equal to 0. Net work done is equal to 0. Gaan terug na jou formules toe. You have 3 formulas speaking on work. You have this one. You have this one. And you have this one. Okay. Now, this one is the only one that speaks about the netwerk. Die netto arbeid verrig. Okay? En hulle sê vir jou die netto arbeid is gelyk aan 0. Wat beteken dit? There's no change in kinetic energy. What is kinetic energy again? Kinetic energy is a half mv squared. Change in means final minus initial. So the mass always stays the same, and you're not halfway going to lose part of your arm, hopefully. But if the network is 0, as in netto arbeid 0 is, then it means there's no change in the velocity. The velocity remains constant. So it's moving at a constant velocity. Moving at constant velocity. Okay, let's read our options. It says there, the object has 0 kinetic energy. Kan ons dit sê? Can we say that? 0 kinetic energy? 0 kinetic energy means it's stationary. Hy staan stil. Okay, it could be that they still staan. Okay, but let's look at the option. The object moves at a constant speed. Yes. The object moves at a constant acceleration. Nee, hy versnel nie. There is no frictional force acting on the object. Ons weet nie. We don't know. Is dit reg? Jy moet een van elk van daarso. No frictional force acting on the object. Ons kan dit nie sê nie. It might be, but it's not 100% correct. Wat ons weet vir 'n feit reg is opsie B. Is the final velocity is equal to the initial velocity, a constant speed. So die opsie daar is B. Nee, as die wrywing groter is as die toegepaste krag. Maar sê maar jy kan onthou jy kan nog steeds my goed is alles weggebak. Maar sê maar ek trek iets oor 'n oppervlak. Oor 'n wrywing. Maar ek sê trek en staan te stoel. Ja, sê die vraag voel ek ook persoonlik daar's 'n bietjie grys areas, maar ek weet hulle soek die antwoord as B. Okay. Goed, dan vraag 1.8, question 1.8. They say they consider the statements below. Work is done on an object when a force displaces the object in the direction of the force. Okay, what do they say there? Work is done when a force displaces the object in the direction of the force. Like that bekend? Yes. Okay, B. Mechanical energy of a system is conserved when an external force does no work on the system. When an external force does no work on the system. Wat bedoel hulle daar, dink julle? Okay, so that's why I want to stop there. What is the definition of an isolated system, 'n geïsoleerde systeem? When the net external forces is equal to 0. That is the definition of an isolated system. Now that is what they tried to say there. Okay, ek dink is 'n bietjie vaag, but they say the mechanical energy of a system is conserved. Wat beteken dit? The mechanical energy beginning is equal to the mechanical energy at the end when an external force does no work on the system. So when there's no external forces. Okay, or the external forces does not act on the system. Okay. Dis wat hulle probeer sê daar. What is this again? That is the law of conservation of mechanical energy, meganiese energie. Hallo, is reg? Wat net een van elke asseblief? So mechanical energy is conserved in an isolated system. So hulle daai definisie probeer moeilik maak en hulle het dit reg gekry, dit was moeilik. But so option 2 is also correct. 2 is ook reg. Okay, and then number 3, the work done on an object by a net force, okay, so the net work done on an object is equal to the kinetic energy of the object. Is daai reg? No, is equal to the change in kinetic energy. So daar's 'n fout. So stelling 1 is reg, stelling 2 is reg, stelling 3 is nie reg nie. So daar's ons opsie dan B. Is dit?
hoop nie die fisies gaan so wees.
En dis nie dieselfde mense wat dit opstel nie.
Ek het my laaste vraag, ek het niks ingevul. My laaste vraag is ook verlos.
Okay, alright, okay. Right, I'll say, which one of the following statements about electric fields is true? Electric fields is mos nou weer when we have that and then the charges, the field lines go away. Okay. There is no electric field inside a hollow, charged metallic conductor. Okay, now this is from grade 11 work that they actually took out. Hulle het dit uitgehaal in COVID, so ek voel so 'n bietjie Okay, maar kom ons kyk. The electric field between oppositely charged parallel plates is not uniform. Okay, so sê net maar jy daar 'n positief gelaaide plaat en 'n negatiewe gelaaide plaat. Okay, like two plates, positive and negative. Then we know it will be in that direction, right? From positive to negative. Is that uniform? Is that the same? Yeah. Okay. And they say it is not uniform. So that's wrong. See, the electric field surrounding a single point charge is uniform. The electric field around a single point charge is uniform. So sê die? Sê hulle is uniform daar rondom. Dink julle dis waar? Ek dink ook dis waar. Then, the electric field between two oppositely charged points is uniform. So, tussen hom en hom. Is that uniform? Nee. Nee? Because here they attract one another strongly. Hierso gaan dit weg van dit af. Dis nie dieselfde. Here and here it's not the same. Okay, goed. So ons is tussen A en C. Between A and C. Now, omdat uit julle syllabus uitgehaal was laas jaar, weet julle dit nie. But when you have a hollow conductor, amper soos, and I don't know if you know, do you know an antenna of a TV of a cell phone? That antenna there? Okay, so dit is uithaal. That there is a conductor, so 'n geleier, en hy is leeg aan die binnekant. If you look on the inside, there's nothing there. Now, ons het hierdie eksperiment gedoen lank terug. Nie julle nie, soos in wetenskapklas, but like I said, it's taken out. If you look inside there will be no electric field. Daar gaan geen elektriese veld wees nie. Rondom, around it, there will be an electric field, but inside it will be like a vacuum. Dit is dus leeg. Daar's niks aan die binnekant nie. Okay. Goed, so daarom is die antwoord A. The answer is A. Okay. So wat hulle hier probeer sê het, okay, is if you look, hier nie by vraag C, by question C, wat hulle wil gehad het is hier rondom 'n enkel, what do they say, this running a single point charge, it's uniform. Dan wat hulle probeer sê daar is when you are close here to the point, then the field is quite strong. Dan is dit 'n baie sterk veld. But when you move further away, it becomes weaker and weaker and weaker. So sê as jy hier vergelyk met hier, dan is dit nie dieselfde nie. Then it's not the same. So if you compare the electric field here with the electric field there it will be much weaker. Daar gaan dit baie swakker wees want dit is verder weg van die lading af. Okay, maar juffrou, hoekom is dit nie dieselfde hierso nie? Wel, as jy kyk, omdat twee plate, because they're parallel to one another, then the field here will be the same. The field here will be the same. Okay, so ek voel is 'n bietjie van 'n triekvraagie, maar die antwoord is A. 1.9 A. Okay, I actually quickly wanted to see if I can show you that. Dieselfde, uniform beteken dieselfde, of konstante.
Ja, ek party goed sou verstaan later aan.
Ja.
Sy prentjies wat ek soek nie.
Om maar die vraag kan was so moeilik geweest. Dit was net die tyd met my hier weer. Maar jou laaste vraag volpunte. Maar die identiteite was ek die identiteit het ek gekry. Dit was maklik geweest. Wat was er nog? Alles is maklik.
Wat lank op pad was daai 3 vorm?
Okay, I don't get what I want to show you now. Ek sal dit gaan soek and then I'll show it to you. Okay, and then question 1.10, vraag 1.10. Okay, sê dit vir jou daar. Oepsie, 1.10. A neutral metal sphere M is placed inside an insulated stand. Or on an insulated stand, an identical metal sphere N carries a charge of positive Q as shown. Okay, so ons het hierso iets en hy's neutraal. It is neutral, so 0 coulomb. And then you have something there that is positive Q coulomb. Okay, and this is M and this is N. Now they say M and N are brought into contact. So hulle word aan mekaar geraak. What is the magnitude, the size of the charge on M when N is taken away? Wat gebeur as hulle mekaar raak? There is a transfer of charges until hulle is gelyk, until they are equal. Okay, so ons het basically last jaar gedoen. The new charge is where you say the first charge plus the second charge divided by 2. Okay, why divided by 2? Want that's 2 charges. So hierso gaan ons sê 0 plus Q gedeeld deur 2. And that gives us Q divided by 2 or a half Q. Nee? Vir elkeen. So daar is ons opsie watter ene? C. C. Okay. Sorry? Die van julle klaar is, begin slank daai prentjie te teken by vraag 2. Okay. Are you done, Tawana? Okay. Right. So, at question 2, vraag 2, is daar 'n prentjie wat lyk soos 'n vloekwoord, né? Nee? Okay. Okay, so jy stres nie. You don't stress, you start to redraw it, jy teken hom oor. Daar's A, hy's 3 kilogram. Then we have something going on there, looking fishy. Okay. Goed, so kom ons kyk net gou na die prentjie. Dis nie moeilik nie, glad nie. Okay, you have something on a horizontal plane, then you have a pulley. What does a pulley do? A katrol. Hy skuif my laat jou hierdie een se regs en links by hierdie een se op en af tel. Okay, so hierdie gedoente maak jou vraag makliker. Hy lyk nie kompleks. Okay, just like we had a pulley, you remember we sometimes have pulleys like this. Nee? Same thing. It allows you to add the left and right to the up and down here. Okay, goed. Het ons al goeders teen op 'n horizontal plane gedoen? Ja. Het ons al goeders teen 'n skynsvlak gedoen? Ja. Is nie moeilik nie. Okay, do you see that angle there? Ja, dankie tog. You like that angle? You see there's an applied force of 12 newtons. En dan die enigste ding wat jy dink, wat gaan hulle daar vra? Is that distance there? Okay. Maar ons worry nog nie nou al daaroor. We don't worry about that just now. The rest of the things I do understand. Kom ons lees. They show you there's a force of 12 newtons op 1 kilogram. The force is parallel to the plane. So hulle sê vir jou daai hoekie is nie teen 'n weird angle daarop nie. Hy is net parallel. The box is connected to an inextensible, so dit beteken net 'n onrekbare, hy kan nie beweeg nie. Box cord of box A met 'n massa van 3 kg. The floor, plane and pulley are frictionless. There's no friction. Woohoo! Nie daar nie, nie daar nie, nie daar nie. Okay, maar before coming to an area marked X, and the masses of the pulley and the cord are neglectable, beteken weglaatbaar. Okay, so hulle sê, daar's nie wrywing nie, daar's nie wrywing nie, daar's nie wrywing nie, hier is 'n klein bietjie wrywing. Okay, so here, I'm just gonna highlight for myself, green, 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 cheese, lekker. And then here, I just make careful, daar's wrywing. Okay, nou vra ek jou, draw a free body diagram to indicate all the forces acting on the 1 kilogram box. En hy tel 4 punte. 4 punte beteken?
4 krag.
4 forces. Okay. So, ons het gravitasiekrag na die middelpunt van die aarde. Okay, then I am going to, how do I say this nicely? I am going to wet my pants as iemand hierdie skynsding verkeerd teken in die toets of in die eksamen. I feel, kan ons nie 'n wetenskap maak nie. If someone draws this at an angle thing wrong, what will the punishment be? 50 push-ups. 50 push-ups? Nee, maar dan gaan hulle dit reg kry nie en dan dit is iets wat almal kan doen. Now, let's say 20 burpees in front. Okay, and then as julle almal dit reg het, if everyone has it right, I will do 40 burpees. 20 per klas. Nee? Sharp? Sit reg? Okay. So, wat gaan jy doen? You are going to take your inclined plane en jy gaan hom daar gaan oorteken with a dotted line, met 'n stippellyn.
Juffrou, is dit verkeerd as ons nie die stippellyn doen?
Nee, glad nie, maar party mense kan net hierdie doen en ek. Nee.
Ja, dit is verkeerd, soos juffrou sê.
Okay. Goed. So remember, jy kan nou hier ook, you can also draw a dotted line here for this surface. So jou gravitasiekrag, your gravitational force is directly down. Not at an angle, it's net reguit af. Then your normal force, the wording there is perpendicular to the surface. Loodreg op die oppervlak, beteken daar's my oppervlak. Jy sit jou liniaal daar neer en jy teken jou normaal krag daarin, your normal force there. Gaan jy die burpees doen, Kayla? Okay. Or daar is en ek reguit tou. Okay. Then we have an applied force there, toegepaste krag. What is our other force? Tension, nee? Spanning daar in die tou. Tension in the rope. No friction. Okay. Ja.
Die benoemde diagramme tel dieselfde hoeveelheid soos die wat die benoem is.
Ja.
Nou, ons skryf ons die letters in, agterbode in, as ons nie 'n vinger op geskryf.
So jy ook kan weet wat 'n krag is wat sê.
Want baie mense het vreemde simbole.
Maar jy hoekom sit jy nie wrywing in?
Waar is die
Want wat het hulle gesê? Is hierso wrywing?
Nee, maar jy sit dan as jy apply force opsit, dan gaan hy mos die wrywing raak.
Ja,
Maar is nog nie daar nie.
Dit voel volgens die teks so werk.
Ons is nou hier. Hierdie is 'n screenshot. Nee daar.
Nou vra ek nie krag terwyl hy so lyk.
Okay. So, ladies and gentlemen, julle ken die rympie, you're special, julle is in my klas, julle gaan dit nie daar los nie, But for the exam, this is your first answer, or your answer, wat jy so los. En dan for yourself, you're going to do the diagrams for both where you're going to split them up, where you're going to highlight. So jy los dit hierso, so, en dan sê jy, goed, hierdie vir jouself, jy doen dit in hakkies, or you can do it at the top of the question paper, or somewhere separate. Okay, gaan jy net gou vinnig vir jouself sê reg. So I want to do it in order. So is die A, hier is B. A's forces, we have tension. Well, it doesn't, there's no friction. Gravity, normal.
Je vrees het natuurlijk. Je vrees.
Ja.
Het is een stukje. Dat is weer maar geladen.
Ach man, doe het er.
Je moet het eigenlijk niet vanochtend houden, toen niemand geschreven het niet. Dus vanochtend 6 uur. Ja.
Moet Jan net geskryf.
Ach, dank je.
Jy weet ek moes kyk.
Kijk.
Ja, dis ook nog
Then
besig
we
gestel.
highlight, dan gaan ons wacht net daar is wat nou. Okay. So this one is linked to that one and that one and that one. Why are they linked? Because they have a pulley connecting them. Okay, daar's 'n katrol wat hulle connect met mekaar. Dan het ons hierdie twee is connected met mekaar en daai twee is connected met mekaar.
Dat is nog een grote studie.
Ja, seker.
As jy dit kry.
Okay.
Heel agter.
Nou vra hulle vir jou, oei, ons het al klaar 2.1 beantwoord. 2.2 vra hulle vir jou, stel Newton se tweede wet in woorde. Sy het net 'n seker aan hoes. Ek het dit sommer as sy die woord nie.
F net is gelyk aan.
Sê weer?
F net is gelyk aan.
Ja, nie in woorde.
Die netto toegepas netto krag op 'n voorwerp versnelling van 'n drukpunt van die netkrag. Dit wil sê versnelling van die voorwerp is 3 keer weer op in die massa en 3 keer weer op in die.
Andersom.
Andere nettokrag op een voorwerp en werk wordt nee.
Wanneer nettokrag op 'n voorwerp inwerk, versnel die voorwerp in die rigting van die nettokrag. In Engels, the acceleration is directly proportional. Baie mooi. Okay.
Omgekeerde.
Hulle het inversely not indirectly. Hulle mag nie sê indirectly. Sê weer? With what? With the force diagram. Kom aan toe net Pakisa. Okay. Nou vra hulle vir jou, calculate the acceleration of the system 6 punte. Wat weet jy moet jy doen? Consider this one, consider that one, stel hulle gelyk aan mekaar.
Soos van twee basies.
O, ek het actually rewards hierso. Okay. Maar ek het al vir julle die memo ook gegee, so dit help nie. Okay. Right, so let's look first at object A. We have F net is equal to M times A. En ons dink hy gaan regs beweeg, so ek kies regs as positief. The force that I have there is just the tension, T, is equal to M times A. Ek weet nie wat is die spanning nie. I don't know what the tension is. The mass is 3 and I do not know what the acceleration is. So that is Formula 1. Then I have object B. Het ek F net is gelijk aan M maal A. Again, it's going to the right upwards. So daar het ek F minus T minus FG parallel is equal to M times A. Maak seker jy weet waar kry ek die formules vandaan. Why do I add? Why do I subtract? Is there something that I'm missing? Okay, so here the applied force is 12. I still do not know what T is. Hoe bereken ek nou weer FG parallel? It's FG sin of theta. Wat is FG nou weer? It's it's mass times 9.8. Nee? Okay. So for this one, the mass is 1 kilogram times 9.8 times the sin of 37. It's gelijk aan 1A.
Juffrou, in so 'n geval maak dit gaan 'n verskil maak as jy dit gebruik as jou konstant of nie.
As jy?
Gaan dit verskil maak as jy gebruik nou jou A as 'n konstant het, maar van die baal as vir die 3 in.
Dan gaan jy T kry en dan moet jy T weer terug in saam A te kry.
O, dit is wat sê dis so die verskil.
Ja, eerste versnelling dan die spanning. Alright, now I'm going to calculate this and rearrange it. So I'm going to have 12 minus het jy dit ingetik? See if you agree with me.
Dat kan je precies verstellen.
Ek is nog nie daar nie.
Kom nog eens hier voor.
Okay, so then we can say let 1 be equal to 2. Then I have 3a is equal to 6,102 minus a. Dan het ons 4a is gelijk aan dit. En a is gelijk aan 1,53 meter per seconde kwadraat. Ek nog eens kyk, ergens is daar 'n fout in die memo.
Ja, ek het nou weer al.
Jy het die antwoord gekry op jou nie van daai.
Daai deel net, ja, ek vergeet dit. Moet ek daai net daar by hier.
Ja.
Dus kan het niet gelijktijdig als een soort.
Ja, dan kan het.
Dus kan ons al uitdagen als ons ook weer dadelijk zon.
Dit is 'n ou manier van dit doen. So, joh, hoeveel jaar terug?
Maar dit is
Die
hier.
Nee, jy gaan presies 'n antwoord kry, maar hulle wil hê jy moet dit so doen. Ja, ek weet nie hoekom nie. Iemand belangrik sit besluit dis nie hoe sit dit nie. kom op universiteit, dan kan jy dit, as dis net al verander het, kan jy dit nie so doen.
Jy moet die clues sommer in
Okay. Goed. Then, any question there? Enige vrae daar? Okay. Then, question 2.3.2. They say calculate the tension in the cord, die spanning in die touwtjie. Okay. Now, different ways in which you can do it. Maar jy kan net sê reg hierso, het ek vir my 'n klein formule gekry om spanning uit te werk. I got that formula. There I have another formula. You can do any one. Jy kan enige gebruik. Jy moet dieselfde antwoord kry. I'm going to choose that formula. And then I'm going to substitute my acceleration in there. En jy kry 4,58 meter per sekonde. Ag, nie meter per sekonde nie. Newton.
4,58.
Dat sal
Is omdat hulle het afgerond daarso. Daar sal 'n range is en soos ek sommer. Ooh, twee goed wat ek vergeet het. They say they calculate the acceleration of the system, not the magnitude, nie die grootte van nie, die versnelling. So moet 'n rigting bysit. Hierdie ene gaan wees regs of up the incline
Mag jy sê die positiewe rigting?
in die positiewe rigting. And then the tension, again they said calculate the tension in the cord, not the magnitude. Now dis moeilik hierso, because are we looking at A or are we looking at B? Want vir A gaan dit regs wees en vir B gaan dit links wees of A wees. Okay? So because I looked at A, I'm going to say that away from A or to the right, whatever. So omdat ek na blokkie A gekyk het, gaan ek my antwoord Taylor vir A werk. Okay, then they say, it happens now that box B experiences a frictional force when it reaches the area marked X. So nou kom ons by daai gedeelte en nou is daar wrywing. Nou vra hulle vir jou by vraag 2.4.1. Where they say, note that the coefficient of kinetic friction is 0.5. How will the acceleration of the system change? Increase, decrease, or remains the same? Wat sal julle sê? Decrease. Hy sal afneem. Hoekom want ons nou wrywing wat hom stadiger maak? Decrease. 2.4.2. Calculate the kinetic frictional force as box B enters the area marked X. Hoe bereken ons nou die wrywingskrag? Is die coefficient maal die normaalkrag. Kan jy sien dit tel 3 punte? 3 marks tells me formula, substitute, answer. Kom ons kyk, gaan ek dit hiermee kan uitwerk? They want F. The coefficient of friction they told me is 0.5. Ek hoor nou net die normaalkrag. If I look at my diagram, daar is die normaalkrag, daar is die normal force. Beweeg hierdie blokkies so op of af? Nee. And I have one force going up and one force going down. En omdat hierdie blokkie nie op of af beweeg nie, moet hierdie twee gelyk wees aan mekaar. So Fn, they will be equal to Fg perpendicular. Kan ek Fg loodreg gaan uitwerk? Ja, dis Fg cos van theta. Okay, so the coefficient is 0.5. And then I have Fg, what is that again? That's the mass of 1 times 9.8 times the cos of 37. En ek kry 3,91 Newton.
Ons regting bytjie daar nie.
Ja. En dit sal wees
Links.
ja, links of af links, skuins links. Okay. So far so good? So the picture that, or the drawing or the diagram that looked scary, was it scary? Glad nie. Want ek hom oor gaan teken. Okay. Goed, volgende ene lyk soos 'n vraag wat ons al gedoen het. Goed, vraag 3, question 3. They say there are two shopping trolleys X and Y, both moving along the right, or to the right along a straight line. The mass of Y is 12 and its kinetic energy is that. Dan vir all of jou, calculate the speed of trolley Y. 3.1 sy spoed, 4 punte. Hulle sê vir my, ek het wat van A. They tell me the mass is 12 kilograms and its kinetic energy is 37.5. And they want the speed, die snelheid, die spoed. As jy kyk na die kinetiese energieformule, then you see, I have energy, I have mass, then I can calculate the speed. So die energie is 37,5, die massa is 12 en ek soek die spoed. En jy kry 2,5 meter per sekonde. And they ask for the speed. Speed in Afrikaans is spoed. Dis nie 'n vektor, dis nie 'n skalaar. Ag, is 'n skalaar, is 'n skale. So you do not have to give a direction. But if you had to give a direction, that would have been to the right. And 3 point... Well, eers gesels hulle. They first say something. They say there, trolley X of mass 30 kilograms moving with a speed of so much collides with trolley Y and they stick together on impact. After the collision, the combined speed of the trolleys is that. Okay, so hulle gee vir jou baie inligting. Maar ek dink daar's 'n fout met hierdie vraag. Laat ek net gou seker maak. Okay, yeah. That the combined speed of the trolleys is 3.2. Daai moet jy uithaal. Dis verkeerd. After the collision, the speed of the trolleys is 3.2. Haal dit uit. Okay. So the velocity afterwards is not 3.2. Jy haal dit weg. Dis nie 3.2 nie. Ons gaan dit uitwerk. Say again? We're not highlighting anything. I've said 3 times now. Not highlight. Remove the part. Remove the part. Sorry, Mama. That says there, after the collision, the combined speed of the trolleys is 3.2. Hold it out. Delete it. Okay. Right, so we have the trolley X, trolley Y, and then we have a collision, and then they stick together X and Y. Hulle sê vir jou hier, hy beweeg regs, regs. Afterwards, they will also be moving to the right. This one's velocity, we just this one was 3.2, and we calculated this one is 2.5. This one's mass is 30, and this one's mass is 12. And we do not know what the velocity is afterwards. Okay, now something that I forgot at the beginning of this question, momentum. Momentum is a vector. Vectors het grootte en rigting, direction. So as you can see, it's moving to the right, moving to the right. So big, I say, let to the right be positive. Okay. Nou vra hulle vir jou by vraag 3.2. Write down the principle of conservation of linear momentum in words. waar jy sê die totale lineêre momentum van 'n geïsoleerde stelsel bly konstant. Okay. Right. 3.3. Can you see there? They say 2 or 0 in die memo. Nee, so dis nie ek jok nie vir julle as ek dit sê nie. Okay. Now they ask a question 3.3. Calculate the combined speed of x and y after the collision. Okay. So ons het die som van die momentum aan die begin is gelyk aan die som van die momentum aan die einde. Het ek hier die data by gesit of nie? Is dit? Okay, quickly go to the data sheet, please. You see that formula is not on your data sheet. It's nie op jou datavel nie. Something that you have to go memorize. Nowhere, if they say the conservation of, die behoud van, moet jy weet, hy is nie op jou datavel nie. Okay? Jy moet weet, die formule beteken die som van. The sum of. Meaning, adding together. Sigma, ja? And you must know, of there at your force block, there we have momentum is mass times velocity. Okay, so at the beginning we have two separate objects. We have the momentum of x plus the momentum of y, and it's plus because they're moving in the same direction, to the right. That's at the beginning, and then we have the momentum of x plus y like that. Want na die tyd is hulle een ding, hulle is attached aan mekaar. Okay. So momentum is mass times velocity. Hierdie ene is 30, sy snelheid was 3.4 plus 12 maal 2.5. And afterwards it's 30 plus 12, their masses together, and then we want their final velocity. Hierdie maak test dit. Maar julle sê dit tel 300. Ag, 150. Saam is dit 3 in my kop, saam is dit 300. 3 ure. So het julle eers 3 ure vrae stel? Nee, okay. Goed. Then we have our final velocity wat ons moet gaan uitwerk. Maak seker jy kan nou 'n sommetjie doen, intik op jou sakrekenaar.
Net 'n bietjie.
Wat's 'n bietjie?
Net 'n meter pas op.
Dit is van 8.
Wat sê jy, Minay? Ja.
Dit was so 'n bietjie met die Engels vandag.
Jy verleer vandag baie. Dubbel. Okay. Right. Then they say, before question 3.4, they say, during the collision, trolley X exerts a force on trolley Y. So they say there's a force, and they say the collision time is 0.2 seconds. Calculate the magnitude, die grootte, of the force, so they want the force, that X exerts on Y. So must we look at trolley X or at trolley Y? Y. We want the force that X exerts on Y. So ons wil weet wat gebeur met Y. Now, when you heard time and you heard force, ek hoop jy het gedink aan impulse. And this impulse formula is always on one object. Dis altyd op een voorwerp. Jy kyk of na X of na Y. Jy kyk nooit na hulle twee saam nie. So impulse formula, you either look at X or Y. You do not look at them together. So they say, what is the force that X exerts on Y? So I'm going to say, I'm going to look at object Y. All the information is on Y. We want the force, the time is 0.2. Then the change in momentum is the final momentum minus the initial momentum?
Ek vra nie vir nou kan ons al twee soms.
Nee,
Werk dit dan alleen.
leen.
Begin was dan die einde.
So wat ook ons kykie? Wat is die massa van A? Was the mass of Y? It was 12. What was the final velocity of Y? Sy het nou net gaan uitwerk, dit is 3.14. Al is die twee connected aan mekaar, maar wat was sy snelheid? Hy beweeg in 3.14 meter per sekonde. So it's 3.14. Minus, what was Y's initial velocity? We got that in our first question, 2.5. En dan kry jy vir jou krag om te wees I get 38.57. Ek het nie afgerond die antwoord nie. Anyway, 38.4, 38.57, 38. Whatever you get, newtons.
Ja, bro, wat is al gewoonlik daai speling met
Kyk, hulle wys vir jou. Hulle gee gewoonlik vir ons in die memos, hulle vat van hier tot hier. Okay, volgende ene, question 4. Oeh, moet ons 'n vinnige breek neem.